Zelda, I have to say sorry for this one, but I've got you.
Who let the dog out?
Oh man.
Oh, goodness gracious. I'm just
I'm
glad
sorry,
you
that's just funny.
I'm just glad he didn't capture my singing the other day. I don't even know what I was singing, but it was horrid.
All right, so good morning. Thank you for having me. It's exciting. There was a lot of, I did a workshop back at Wild West Hackin Fest in October, the virtual version, and or I guess it was September actually. And there was a lot of great feedback from it, and there was a desire. We ended up kind of having the last like 15 minutes be a flurry of questions that sort of inspired and led into this talk. So I'm going to try and keep up with what's going on in the Discord as well. So if you have questions, feel free to put them there, or I'm sure the moderators will shout at me if I miss something. So my goal here, so I come from Lawrence Livermore National Laboratory. I do a whole bunch of different cybersecurity related things there, but I also have been helping to evangelize some of our open source work. And so we have a large collection of open source. That's not what I'm here to talk about. But being involved in open source has really inspired me to try to make that a part of everything that I do. And so I know that there's a lot of great open source tools out there for cybersecurity in particular. And I think there's a lot of confusion or a lot of, I'm not a developer, I can't do open source sentiment that's out there. And kind of the main thing, if nothing else, that I want you to take away from today is that that's not true. Fundamentally, I actually had this conversation with my wife last night. Fundamentally, like anyone can contribute to open source. And I think that's gotten a lot easier in recent years. And hopefully, if nothing else, that's what I want to leave you with today. So focusing on Python, just because there's a lot of great other material from Black Hills and elsewhere to refer to for how to make a Python project, how to do different things in Python. There's obviously different languages. A lot of what we're going to talk about here is very, very portable to other languages or other frameworks. So, but I'll focus on Python because that's the one that I like. All right, so first thing we're going to kind of dive in a little bit, kind of like a quick primer recap from the workshop. That video is almost up on YouTube from what I understand. So you'll be able to catch that in the fuller version in a bit, but I just wanted to give a quick intro, right? We advertised this as being not requiring any knowledge in advance, other than, kind of know your way a little bit around a command line. And I hope that we'll be able to just build from that. And then I'll show how you can contribute to some other projects. This was sort of what we were outroing in the workshop. And then we'll spend the bulk of the time, not really in the slides, but actually working on starting your own project. So that's what we'll do. So what is version control? So what is Git? What is open source? So when we talk about open source today, what we really mean in most cases is some bit of code that's available out in the open. So people can find your code, they can contribute to it, they can change it, they can modify it. That's typically what's meant by open source. And that comes from having something in a version control system. So Git right now is the predominant one, but there's other options. And it really is jumping off of this idea of if I have a script, or if I have a Word document, or if I have something like that, I don't want to have to keep, as you can see on the comics here, changing the file name every time I change the file, right? I want to be able to track, I made this change on this date, maybe here's a comment about the change I made, and try and keep that all somewhat sane across your own history. And beyond that, once you start having an open source project, you most of the time are doing that because you want someone else to pick it up and use it. And maybe you want other people to contribute back to it. So you actually want a way where you can keep track of not just your own changes to the code, but someone else's changes as well. So I mentioned there's a couple of different options under the umbrella of version control tools. Git is the predominant one. That's the one that GitHub is based on, GitLab is based on, Bitbucket's based on. Mercurial is another similar one. And then Subversion or Perforce are two others that you might commonly hear. Subversion was the sort of 800-pound gorilla up until, I don't know, maybe 5-10 years ago. And then Git took over that, and that's the predominant one. And someday maybe that'll change to some other tool, but that's the one that we have today. The main differences here, there's sort of two subfamilies. One is a centralized version control system where there's one server, there's one golden copy of the repo, and everyone contributes to that particular copy. And the other version, the subfamily is distributed version control. And so that's where you can have multiple different copies, and there isn't necessarily, other than sort of a gentle person's agreement, if you will, there's no real distinction between which one is any more central than the others. They can all be central. So I kind of alluded to this earlier, and this is really what this talk and the workshop before it, are trying to address. Is there's a lot of fear and concern about Git, and it's not all necessarily unfounded. I think this XKCD comic does a pretty good job of explaining, how a lot of people approach Git. Is basically there's all these crazy commands, there's these subcommands, there's sub options, there's anywhere between 5 and 10 different ways to do the same thing potentially, and it can be a little daunting. And so what I want to try and emphasize is there's ways where you can sort of wade into things and not have to eat all of those 10 different permutations of how to do something. So that'll be one of the big takeaways that I hope you get, and we'll see what we can do to hammer that down. So Git, I'm not really going to dive too much into the commands. As we get into the later part, we're actually working on a package example and turning that into what could be considered an open source project. We'll see kind of live what the commands look like. So I'll focus on the syntax there. Also, again, there's a previous workshop where we went into more detail about the different commands. But I want to pause here because this, I think, is a graph where we can see visually how Git is working. And so fundamentally, when things start off, they are, let's get the laser pointer out here. When you start off, you have a Git repository, and there's nothing tracked. Everything's in this untracked state over here. These are the Git terms these are the terms in Git for what these different statuses mean. So everything starts off, it's untracked. It's in a directory. That directory happens to be a Git repo, but Git doesn't really care about that file in any way. I suppose there's also a fifth stage here, which would be ignored, where Git knows that the file's there, but it doesn't care about it. It's not going to try and track it. So when you're in a Git repo and you have some file, what you'll do is you'll eventually want to add that in, right? You'll make some changes to it, you'll write out your code, and eventually you'll want to add that into the repository. And so the git add command is for taking that file and staging it into the repository. And what it means to be staged is this is the collection of changes that you're building up that you'll eventually turn sort of commit is the term into the Git repository. So you can take one or more files, you can take pieces of changes of a file. Let's say you made sort of a top, middle, bottom change to a file. You could choose to take just the top and the middle, top and the bottom one, and leave the middle one in there and not commit that at first or on one pass. And so you can add all these different pieces. And when you do, they go into this staging area. And Git does a pretty good job in the last several versions of being pretty explicit about, this file is staged for commit, this file is unstaged, these files have changes, these ones don't. So there's a lot of information on the terminal. Everything I'm going to show is going to be from the terminal, mostly because if you understand what Git's doing on the terminal level at the command line, then applying that to whatever your favorite tool is will be a lot easier. If I tried to show a particular tool, trying to get that mapped over to a different tool or back to the command line can be more challenging. So when you take a file, you'll add it in for staging, add it into the staging area, and then later on you could say commit. So you could say git commit. You can give it a message about why you're committing that file, and it will go from the untracked to the staged, and then from the staged down to the unmodified. So this means that Git has a copy of that file. It's in its version control. You could go back to it at any time, but it's unmodified, right? I haven't changed that file. And then the cycle might go, well, I make a change to that file. And then because Git knows that file, because I previously added it, it'll end up in this modified state. So Git will know, hey, there's this file, readme.md, and that's in my history, and you have some changes to it. And I'm just kind of telling you those changes. And so to stage that, you'll use the same git add command, but you can move that from the from the modified state into the staged state with git add, and then you could later go ahead and commit that. If down the road you decide, I added this file and I really didn't want to add it, then you can git remove the file, git rm the file, and that'll take it from an unmodified state into an untracked state. Now, and so then and by default, it will also actually delete the file when you run it with the command line. And why might you delete a file? Well, you might have changed something. You might not need that functionality anymore. Another example that or another use case that I'll point out, because there's a bit of a gotcha, is let's say the reason you want to remove the file is that you accidentally checked a password in. Right? You were working on some database. You took the password, you put it into your script, and then you went ahead and committed that into your repository. You really don't want that password to stay in there. And so you might think, oh, well, if I remove this file, it will take the password out of the history, but it won't, because once you've committed it, it's in the history forever unless you take more stronger action against it. So there's a fair bit of nuance there that I'm not going to go too much into, but just to know that if you're trying to remove a file, when you do, it does not remove the past history. There's extra work you have to do to get it out of the history, which is possible, but it is challenging. And as we get to talking about taking that repository and pushing it out to a server, like GitHub or GitLab, then once you've pushed it, there is no way to pull it back, right? Someone, as soon as you pushed it, could have cloned it down on their own side, and removing the file locally and even pushing that to the server doesn't necessarily mean that someone else hasn't gotten that file. So anytime you check a password into a Git repository, do me a favor and just go ahead and change that password. Right? Use a random string generator and get yourself a new random password. So the piece that's not here that I just sort of mentioned and glossed over is pushing. So all of these operations, adding, editing a file, staging it, committing it, removing it, all of these and their corresponding git commands, git add, git commit, git remove, are all done locally on your local machine. So you have a Git repository, it's sitting on your hard drive, and you can do this to your heart's content. And that'll build up a history of the repository. And then you can later choose to push that repository, push that repository and those changes in that state off to someplace else. And the most common case is going to be pushing it to a single server, but you could actually have multiple different, what are called remotes in Git parlance, where you push that code out to multiple different locations. So this is a good graph. There's a link here to the Git documentation where you can read some more detail about what all these stages are and check my words here. So as we talk about committing into a repository, it's important to kind of pause. And again, there's going to be a couple XKCD comics in here because it's a great resource where there can be a tendency to have not great commit messages. And really, the reason you put a commit message is actually so that you later looking at it have an easy to digest understanding of what happened, right? You don't want to necessarily go read the source code of all the changes, but you want to know what happened. So you want to really try and avoid putting commit messages like this. Here you can see at the top, they started, fairly descriptive, creating a main loop, then enabling the config file. And then it goes kind of less and less helpful commit messages. And this can be a temptation, but I would challenge you to try to keep good commit messages going. And especially as you start working with other people, if you make an open source project after today and you start getting some commit contributors from outside of your sphere, then having these commit messages can be helpful, especially when you start trading commits back and forth. Just a quick note here about branch names. So there's been a bit of a shift in the in various open source communities that have changed names. So you'll see two sort of primary branch names. You'll see master as a branch name that had been the old convention. Main is largely emerging to be a new convention for the primary branch name. So you'll see those two, and those are really just know that they're typically the same thing. And the branch names are fairly arbitrary. That's just what the default what repositories start at. So, okay. So I talked about the staging and the pushing and the pulling, and so I wanted to give a little bit of a demo of what that looks like. And in past years, that had been as a, taking a repository and load for me. Taking a repository and actually making some changes and adding them and looking at what the status is. And we'll get to that a bit later as we talk about the, actually building a project. But for right now, just to give a high level of kind of at the commit level, where we don't have to worry so much about the content itself, I wanted to pull up this website that I found. This is actually made by GitHub, the folks over at GitHub. And it shows a little bit what I'm talking about when I say that there's a local repository. So here on the left side, we've got a local repository. This is your hard drive. And then origin here, origin is just an alias for a remote server, right? So origin is the short name for something like git@github.com /Ianlee1521/awesomeproject.git or something like that, where you don't want to type that every time. So you can use origin instead. And so this is a JavaScript emulator. This isn't exactly a full Git implementation. So there are a few quirks with this, but it allows me to do things like just demonstrate, okay, if I make a commit on my local repository, it started off, it was synced. I'm going to undo. It also has an undo button, which unfortunately Git does not have. So here you can see there's a couple of things. We have a commit. That commit has a hash and a comment. Here the comment is just first commit. And then we've got a couple of other things here that I just want to show. And this is all happening largely in the background of Git. So you have a local branch, in this case master. That's what this yellow box is going to be. Then there's a pointer to the current branch, which is head. So head is kind of a constant term in Git, and that points to where in the repository history I am. And 99 out of 100 times, head will always be pointing to a particular branch, in this case master, and that particular branch is in turn pointing to a commit. And that commit is what actually represents the code that you have. So the code is encoded in this commit blob, and it's referenced by this hash. Now, what's important to note is this hash will change anytime you make a new commit. You'll get a new hash based on timestamp, who authored it, the changes you made, what the parents to that commit were, what were the previous versions you're coming from, and all of that gets encoded into that hash. And so in general, all these hashes will be unique. Although in some very, very large projects, they're starting to run into the case where they're actually starting to run into collisions, and that's causing different hashing algorithms to come in, but not really the point here. The other thing you'll see is this gray box here, and this is saying origin/master. So this is saying I, on my local repository, know about a remote that I know as origin, which again just points to some URL. And on that origin remote, there is a branch called master, and that branch master points to this commit. So here it's kind of shown as a stack, but you could think of these all as pointers. And so master points to the commit, origin master points to the commit, and head points to master is how you would kind of interpret this if there were more arrows. And so when I'm going ahead and I'm making my changes and I'm posting them or committing them rather, if I make a commit, it'll generate a new commit, new hash, right? I made some other changes. You can see head is still pointing to master. That's the current branch I'm on. And master is pointing to a new commit here, F9A6, blah, 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 blah. And this commit, in turn, is pointing back to its parent, which was this first commit. Now, the other thing you'll notice is the server hasn't changed. The server knows nothing about this new commit. And therefore, our local reference to that remote server also hasn't changed. So here we've got an origin master. master's over there. I've got a new, more updated master here. So I could just keep going ahead here, git commit, git commit, git commit, and I could just keep doing my changes. Now, what I say when I talk about pushing to the server is there's a separate command. So I could do this forever, right? I could have no origin. There's no requirement to have an upstream or a remote server that you're talking to. And this, by the way, could be a file system, right? This could be an NFS system. This could be all kinds of different things. But by default, what you'll want to do if you do want to publish your changes is you can push these back to the server. So if you run git push, there's a couple of other options that you can use to this. Again, there's going to be 5 or 10 different ways to do just about anything here. But if we go ahead and we push these commits, what you'll see is the commits that I made will get pushed to the server. I made locally will get pushed to the server, and that server state gets updated. So master moved from pointing to this commit here to pointing to this commit here, and then there's a remote head that points to that same master. And then locally, because I just talked to the server, git push was me communicating with the server, and I made the changes there, my local pointer, origin master, that had been pointing to this first commit is now pointing to the same commit that I have locally that I pushed. So if I just undo this, and just to show it again, and so git push, you'll see that origin master will get updated, and these 3 commits will end up showing up on the server. So that's a fairly simple workflow. Now I can go back to git committing some more things, and then I can push them to the server. And so at a minimum, right, if you're working on a project, it's just you've got a Git repository. If you take my sort of outro call to action here at the end, pretty much everything you work on going forward, anything that's code or documentation or anything like that, that's a text file. I'd really encourage you to put into a Git repository. So this is something you could do with yourself and not have to have your script version 1 through N anymore. So let's go ahead and clear all that out. And I'll just kind of show a different use case. So let's say I'm going ahead and I'm doing my work, and maybe I've pushed that to the server, maybe I haven't. And then once I do this, maybe I decide, hey, you know what? I want to add this new feature, but I'm a little unsure of it. I don't want to do the commits directly on this main branch, this main state here that I'm publishing to the server. Instead, what I want is to actually make a branch, make a deviation from this state and do my changes over there. And maybe I'll decide I'm happy with them and want to merge them in later, or maybe I won't. Maybe I'll just throw them away eventually. So the command for that is going to be git checkout with the -b flag. So git checkout -b says make me a new branch, and I'm just going to give it whatever name I want. And so for right now, I'll say new feature. And so here you can see the things moved around a little bit. And I'll say it would be really nice if this had arrows for the branches, but alas. So here, head, so the current branch that I'm on is now pointing to new feature, but there's also a master branch and a sort of knowledge that the server is also at this point here. So when I go and do my commit now, what you'll see is that master, the branch I was coming from, will stay the same. It'll stay pointing to that commit, and new feature will advance by that one commit. And I can go ahead and I can do the work on my new feature. You'll see that head, again, just being a reference to this is where I am in the repository. This is the branch that I'm on. Head is following along with new feature because that's the branch that I'm on. You can see that also denoted up here in the top of the UI. But this other branch will stay right there. So now maybe I decide, okay, I was working on that feature, but I need to go back and fix something in master. And so I can go ahead and I can check out master if I'm not making a new branch. I don't need that -b flag. So I can get check out master. That'll move the head over there. You can see the icon here moves, head over here moves. And I can go ahead and I can fix whatever thing I needed to fix. And that'll make a new commit that points to that same parent, A35B6, blah, blah, blah. And The remote server stays here. My new feature is still hanging out over there, waiting for me to get back to it someday. And the current branch that I went back to fix something on is over here. And so what I can do with that then is maybe I decide to publish that to the server. So I can push that out to the server. Great. That'll update the server. It's the server's copy, as well as my local reference to where that server was the last time I checked in with it. And these points are pointing here. Now with git checkout, I can go back and forth between the branches as I feel like it. I can go git like that, and I can do some more work over here. And I can jump back and forth. So I can git checkout master, do some more work here. And so this, you can start to see what's happening in the local repository as well as on the server. Basically, not a whole lot happening on the server. All the work's really being done locally. And this is where, before, when I was saying that when you remove something, right, if this commit, let's say, was removing a file, all of this history, all of the state that was in all these commits stays. So that's what happens there. So now let's say we've been working on this new feature, and now we're happy with it. So we're happy with this. We got it to the point where we like it to be. And what we want to do, I'll just update I'll just do this. Go back one. Let's say we're happy with that new feature, and we want to merge it into the main branch here, the master branch in this case. So what we can do is use the git merge command. And this is going to merge some other thing that I specify into the branch that I'm on. So in this case, I'm on the master branch. And over here, there's a new feature branch. So let's say I want to merge that branch into the branch that I'm on. So git merge new master, new feature. There we go. Will allow me to combine the changes. And so any changes that I made on that new feature branch will get combined with the state on the branch that I'm in, and this new merge commit will get created. So here it has its own hash, and here you can see it actually has two parents, right? It came from this master branch, but it also traces its lineage back to this new feature branch, and that's sort of visually represented here. And I could go ahead if I felt like it and push this out to the server. And you can see the graph is a little wonky, but you can see functionally that all the commits that are here, right, CC381 is right there, 984 blah, blah, blah is there. This 05D came along as well over here. And this new merge commit 6FE is right there. And so that state's updated. Our branch is updated there. Move that out of the way. And you can see nothing actually happened to that other branch, but my branch that I was on that I merged into is updated. Now I could go ahead if I wanted to, and I could say git branch-d for delete new feature. And so what that'll do is that'll delete the reference. Now, the way I like to think about branches, and I think this particular way of visualizing the repositories lends it out, but I actually used to do this when I was teaching on a whiteboard in a conference room or something, is branches, references, the head sort of special reference. I like to think of these as sticky notes. There's no real sense that master or new feature is a particular change or is a particular state. It's merely a pointer saying, hey, I don't want to have to type 9A933 blah, blah, blah every single time I want to get back to this state. I just want to type new feature. And so this is a sticky note, an alias for that commit. And as a sticky note, and as we've seen where we've made new commits and the branches have moved along, those sticky notes can just get picked up and moved. And so one way to demonstrate that, we'll see if the UI here will play nice with me, is as I move to some other branch, let's say I'm on new feature, and let's say I decided, actually, let me go ahead and do this. Let me do, this will work. So I'm on this new feature branch, and let's say actually, you know what? I'm going to use the master branch. So we'll say git checkout master, since that's a little more of a real example. Let's say we did this merge, and then we decided, you know what, I actually didn't want to do that merge. I want to go back here. I don't like this change. This new feature needs to bake a little more. I mentioned that, here in this UI, we have an undo button. In the real world, we don't unfortunately have an undo button. We don't have Control Z. Maybe they should add that, but it's not there yet. So what you can do if you wanted to move the branch, move that sticky note, that master sticky note around arbitrarily, is you'll use the git reset command. And there's a couple of different options that controls exactly what happens with that, whether you're just moving the sticky note, whether you're moving the sticky note and also changing the state or leaving the state. So for instance, in the default mode here, maybe not the default mode, the clearest to understand mode, I think, is explicitly has the -- hard, so git reset hard, says update where the branch is and update my local directory to match the state where I'm moving to. And then I can give it some other reference. So this could be a branch. I could say new feature, and that'll go ahead and that'll move master down to where new feature is pointing to, which is this 9A93 commit. Or you don't actually have to use that commit, right? Or that the branch name. You could actually just give it the hash, any arbitrary hash. So 0, and you don't have to type the whole thing. You just have to type enough that Git can disambiguate which one is which. So 05D590A will move master over to that point. And so I could move this commit arbitrarily wherever I want, E137. Move it over there. Let's say I decide, you know what, no, I actually was happy with that change. I can move it back over there. So you can use the reset command to move that sticky note, just pick it up and move it to whatever commit you want. Now, one thing you may have caught when I did git reset hard new feature is these commits here are kind of grayed out. There's a little bit of nuance. I think technically what I'm about to say doesn't apply if this state is here, but let's say this sticky note wasn't here. Let's say this was over here somewhere. These commits here are called dangling commits. So what this means is there's not a reference, there's not a branch that points to a commit where these commits are in the ancestry of that commit. And so you kind of see that clearly, right? These commits all point back down this line. These commits rather, do not have any branches pointing to them. Again, ignore that one there. I think that's a bug in the UI rather than the Git thing, the Git workflow. And so what happens is initially, nothing. That commit is stored in Git and it will stay there for some length of time. There's different default options for this, but that commit will stay there. And that's important to know that once you put the commit in the Git repository, just moving the branch around, just removing the file does not immediately remove the content from the repository. And in this case, because now not ignoring the branch, let's say I had pushed to this over here, then that server has those two commits. So if I, let's say, put a password in my file here and pushed it to the server, then that password is on the server. And that means that it is at least possible that someone could get that password out of there, right? It's not just on my local computer. So that's one of the nuances that I mentioned earlier, that, again, best practice is if you commit something that's a secret, password, credential, token, whatever, into a Git repository, and you didn't really, really mean it to be there, assume that it's going to be compromised, assume that someone else will find it. That's going to be your safest bet. Okay, so there's kind of a couple of examples there of how you would go through and actually make changes to a repository. So I want to show one other thing that comes up a lot as a question, is arguably a little bit more of an advanced topic, but that would be my year-and-a-half-year-old in the background. A little bit more of an advanced topic maybe, but I think is important. And I think a lot of people ask questions about it because they've heard, okay, there's a git merge command, but there's also this rebase command I've heard about. What is a rebase? So let me go ahead. I think there actually might be a scenario up here. No, not a specific scenario. But and I'll talk about this a little more later, there are a couple of different scenarios you can get to in this, this tool. So let's say I go ahead and I make some commits. Then I say, okay, well, what I really wanted, actually, we're gonna ignore the remote server for right now. So we'll go to just the free explorer. So git commit, right? I made some changes. Then I went ahead and I said, okay, well, I'm gonna work on a new thing. I'm gonna work on that for a while. Then I'm gonna say, oh, well, I need to actually go back. Oops, I need to not undo what I was doing. Not think that I'm actually in a terminal. Git checkout master. And then I'm going to go back to that branch and I'm going to do some work over there for a little bit. And then I'm going to come back to my new thing, my new branch. So I'm going to git checkout new thing. This is mostly just me setting up a state, which again, used to take forever in using a real Git repository. Okay, so I'm back here. Now, let's say I was making these changes, right? And let's say this master, these changes were from like a month ago, and maybe instead of 3 commits here, there's 300 commits here. If I want to go back to working on new thing and adding that in, one option would be while I'm on the new thing branch here, again, head is pointing to new thing is pointing to DFA6, that particular commit. One option would be I could git merge master. So I could pull the changes that have happened in the master branch into my new thing branch. And that'll create a merge commit. It'll have the 2 heads, or the 2 parents rather, pointing back to the 2 different parent commits. And that's fine. That works for a lot of use cases. And honestly, for me, this is typically my workflow. And we'll just undo that. But let's say you didn't want to do that. Let's say for whatever combination of reasons, instead of having that merge commit and where you get this, kind of 2 parallel branches, let's say you're working on a project where you really like that linear history. You really want every commit to only have 1 parent, which is in some sense more of a stylistic choice, although it does make certain things easier. So what you can do then is, instead of doing a merge, you can say git rebase to the place you want to rebase onto. So in this case, we'll say master. So git rebase master while I'm on the new thing branch. And so what this is going to do, I'll hit enter in a second, but what this is going to do, and we'll go back and forth a couple times, is that's saying, okay, I made these 2 commits after I left the master branch. But master went ahead to here. Master's more evolved now. It's over here. And what I want to do is I want to go back to where those 2 branches diverged, the one that I'm on and the one that I'm specifying. Go back to that commit. And now pretend that all the commits I made here on new thing, that I didn't make them based on this commit, this 7AB commit here, but instead, let's rewrite them as though I made them starting from B58B. And I think the visualization here is pretty clear. So what it'll do is it'll move the head over to that new branch, and it will take the content of each of those commits, the changes you made in each of those commits, and it will replay those changes onto this new branch. Now, a couple of things to note. One, by default, in sort of a standard, in a typical rebase workflow, is it will take that commit and it'll take each of the commits in order. And another thing to notice is they're different commits. So the hashes here are going to be different, even though it might be exactly the same actual change. And again, that goes back to what gets hashed into the hash here, what information is put in it. It's not just the change, it's also who made the change, when the change was made, and the parent of the change that you're making. So in that case, the B58B, blah, blah, blah. So you're going to end up with a different commit hash, and you'll be over here. And again, those 2 commits are not gone. They're still in the repository. If I decided, no, I didn't like that rebase, that just doesn't work for me, I can go ahead and I can reset back to where I was, DFA6. Because there's no branch, I have to refer to it from the hash. So DFA6, and now I'm back over here. Those 2 commits that I just made from the rebase, they're also still there. And there are ways, there's a concept of garbage collection in Git that typically runs after like 30 or 90 days most of the time. But there's ways to trigger that to force that to go manually instead.
Hey, Ian.
So yeah,
Sorry, do you have a minute to answer a few questions I've been seeing?
sure.
All right. And I apologize if these are things you've already answered since they've been asked. Ken wants to know, how often should you do a Git commit? What are some sane criteria to keep you from wanting to do it for every edit/save of a file?
Yeah, so I like to, I say commit often. I would argue that committing more is better than committing less. Partially because it becomes your save button, right? So git commit to me is my save button. As far as what to put in the commit, I would say if there's sort of a logical change, then I'll do that. And part of that is inspired by the commit messages, right? There's no requirements, but there's some standards for Git messages where the first line should be 50 characters, then a blank line, and then you can put basically whatever you want, describing in more detail what's going into that commit. So if you take just that first line, that 50 characters, right? Can you describe what you did in this commit in 50 characters? If it takes you more than that, you're probably including too much in the commit, or you need to use the subdescription to really go into the detail. So if you're trying to say like, I did this and I did that and I did that, that's probably 3 different commits. But that can be 1 file or that could be 100 files. So some examples are like if you added logging to your project, then you might add that to all your different Python modules all at once. And that might all be 1 commit, right? Added basic logging to my project. And that could be across 100 different files. So that's kind of my rough rule of thumb.
Awesome. And then is push equal to check-in? How do we know which code files were checked out or checked in?
So that'll become a little more clear when I get to a real Git repo that we'll be working with. But there's a git status command, which doesn't have a place in this particular emulator UI website thing, but git status will tell you which files are staged, which ones are unstaged. And then as far as what's actually in the repository, it'll tell you if there's untracked files. That's a signal that, hey, this file is in the directory I'm in, but Git doesn't know anything about it. And so that therefore it's not checked in.
Okay. And then one more question for you. If you could change the Git global fig, say new author email address, would Git rebase work here too?
So if you change your author, let's say you changed your email address, if I'm understanding the correct question correctly. So if you change your email address, that will affect new commits going forward. So when I make a new commit, it'll use that new email address, but it won't change any of the previous commits. I'm trying to think if rebase, there's probably a flag that's something like update author or new author or something like that, or you can just tell it the author, and that'll use the information you specify for those new commits it creates. Under git commit, the git commit command, there's an argument you can use --amend. So it would look, I don't think it's going to work in the UI like this, but git commit amend. So if I made a commit and then I was unhappy with the message or I was unhappy with the author, you could use this amend command to change that message. There's also I think it's like --fix author that will allow you to change the author that you were. So hope that answers the question.
Awesome. Thank you for answering those, Ian. I'll let you get back to your flow.
Sure. Okay, so before we move on to, out of the just a Git primer into some real examples of the open source part of this, I want to show one more example, which is actually right here, which is when you start working with multiple people, right? You're not the only one. You're not the only person. Work with me here. There we go. You're not the only person. So over here, where I was, pushing and pulling, and my local knowledge of the server was kind of always in sync because I was always the one making those changes. Then, which may get to the question that just got asked in Discord. So in this case, you have multiple people. So here's kind of a basic setup that you might run into, where there's a master branch and a feature branch. And locally, I know about feature, I know about master, I know where origin master is, and I know where origin feature is, or I know where these were the last time I asked the server, hey, where are those branches pointing to? What are those pointing to? Now, let's say someone else is coming along, Shelby came along, and instead of my state of the world, right, she was also working on this feature here. And so you can see this hash here is the same, 1C01, 1C01. So this is the same commit. So this is where I knew it was. But unbeknownst to me right now, Shelby went ahead and updated feature, right? She was adding more information about it. So if I try and make a commit, and I'm going to show a couple of different ways of this, so bear with me. If I go ahead and I'm working on feature, she was working on it, she beat me to pushing it to the server. So I was over here, I was working. If I try and do a push, the server is going to get unhappy with me. And what's happening here is this commit history doesn't match what the server knows. So the server is like, hey, my current version of feature is this hash FD0, and you don't seem to include that in your history. So I'm not gonna do anything about this. And here the message is a little terse in an actual modern Git client. This is actually a pretty verbose message that really helps point you in the direction you need to go, but try pulling first. So here we introduce a new command. We were using git push to push our local commits up to the server. So there's a corresponding git pull to pull commits down from the server. And so what this will do is it'll pull down the new commits. So it pulled down the state of the server, origin feature is right there, FD0, blah, blah, blah. And then what git pull does by default is it will merge where I was with where the server was. And so it makes this new commit here that points to these two branches or it points to these two parent commits, and that's where it is. So now if I go ahead, I might say, okay, well, I included the work that I was just working on with the work that Shelby had pointed. So now I'm going to push that up to the server. And UI is not going to like me here, but you can see that all of those commits then show up on the server. So now we're both in sync. On Shelby's side, she can go ahead and do a git pull, and she'll see the changes that I just made. Now, this is where that sort of linear history can start to get a little wonky or a little desirable, because right here it starts to become a little tangled, who's working on what and what it was based on. And so there's some things you might want to do. So instead of pushing that commit out, so let's go back to this state. So I've merged here. I did my git pull. I got the commits. But let's say I want to say, okay, well, yeah, I was working on this while someone else was working on this. But really, I'm going to take my commits and I'm going to rebase them. This is a good use case for rebase. I'm going to take them and I'm going to rebase them onto the state of the server, right? I want to try and get back as much as I can to that linear system. So if I do a git rebase origin feature, then what that'll do is it'll take these three commits and replay them as though they were made on the origin feature. And one thing to note is that, and I believe this is true in a real Git client as well, the merge commit will probably come along as well, but there's probably not going to be any changes there. But just so you see. So now if I go ahead and push it, rather than all that sort of, what starts to look a little bit like an octopus going along, now I actually get these commits all in a straight line, which again is a little bit of a stylistic choice, but can also be helpful for making it clear, how things are based off other things. Something else, and I see at least a word in the chat coming along with this, is when you do this merge, right, one of the things this UI kind of glosses over, because it's only really showing the commits themselves, is there can be changes. So one example or there can be conflicts rather. And so one example is, let's say there was a function, foo, and it had, or let's say it was a variable, right? Foo equals 1, and that's what it was here. And let's say I over here in 417 changed it to, foo equals 7. And then again, picking on Shelby over here, she made the change and she picked the correct answer of foo equals 42. So previously foo equaled 1. I changed it to foo equals 7. Shelby changed it to foo equals 42. When I actually do this merge or this pull that triggers a merge, Git doesn't know which of those two answers is correct. All it knows is I changed it one way and someone else changed it another way. I don't know what to do. So basically Git saying, I'm giving up, you have to solve this problem on your own. And so what it'll do is it'll produce a conflict and it will stop in the middle of the commit, basically right before the commit. And it will give you the opportunity to fix up that commit. So it'll actually make a change to the file. There'll be some little rails, and then basically on one side it'll say foo equals 42, on the other side foo equals 7, and then I have to actually edit the code to be the correct value, which can cause some errors. And that's potentially why you might want to rebase, because maybe she changed it to 42 and I want to change it to 7, and with a better commit message of why 7's the better answer. So rebase might be the right answer there. So there's a question about rebase versus reset. Just real quick, rebase, again, is saying take all my changes back to some point and replay them someplace else. So take all these changes, 46C through AF8, for example, and replay them someplace else. So if I did a git rebase origin feature, that's going to take my branch and replay it going forward, right? And again, there can be conflicts here, but you'll fix them up at each commit. And so that gives you an opportunity to put a better commit message, do other things. There's another option or another mode you can do this in. I mainly get to it by using the -i flag, so git rebase -i, and then wherever I want it to rebase to, which is interactive mode. And what you can do is you can actually squash these commits, what's called squash these commits. And so instead of having 4 commits here that are all the changes that I made, I can combine them all into one new commit that's based off another point. And this is useful for when you're sharing with other people. You want the not just like I was fixing a thing. Okay, it's finally correct. You really just want that correct state. And so you might want to squash all these commits together. But I would recommend you to go read the documentation on that. Again, some of this is stylistic. It doesn't actually change the final state of the code, just what is in the history. For a reset, as opposed to a rebase replays the commits. Reset, again, is just saying, with the --hard, is saying change my local directory structure and move the branch tag to some other place. So I could say anything I want, really, but let's say I wanted to say reset this to, okay, I was making some changes, I was doing some work, but you know what? What Shelby did was way better than what I did. I'm just going to throw my stuff away. So I can just git reset --hard origin feature, and that'll just say, basically ignore what I was doing, all these commits down here, my attempt to rebase the commits up here, and we're just going to point to origin feature, the version that's on the server, effectively. Okay, so now I'm going to reset this and show one last thing before we move on to sort of some real examples and not just playing around with a graph in a web browser. So git pull is what we did. I'll just do a git pull real quick. Pulls down the commit, or fetches the commit and updates the branch to point to it. There's another way to do that. So that does get the commits from the server and update my branch to what that branch said it was. But there's a different way to think about it. So git pull is really a combination of 2 other commands. It's a git fetch, which says get me the commits from the server, and it's a git merge, update my local branch with some other branch, which by default is the same branch on the server. And so if I do that, I can break this down. So I can run git fetch. I'm on my feature branch here. Let's make this even more clear. We'll say I'm on this commit here. I was doing some work. The server had some new commits that I don't know about yet. I can go ahead and I can fetch those commits. And so that'll pull that commit down. That's this FD0 commit. And because I did a fetch, a pull, and a push will all talk to the server, I now know that there's this new commit, and that's where the server is pointing to. So now I can, at my leisure, decide whether or not I want to do anything about that commit being there. So I could decide, you know what, I'm not going to worry about it right now. I'm going to keep working on my little branch over here. And eventually, I could do a git pull to check in again with the server and see if feature changed any more and merge in my changes. Or because, let's just say I did a git fetch, I would get the updates to the server. In this case, there are no changes on the server. So I could say git merge origin feature. And so this will manually then create that merge commit that points back to the server commit and the commit that I was working on. And so what this will do is git fetch plus git merge equals git pull with a little bit of hand waving. What this means, though, is that git fetch is always a safe command to run. It will not affect your local copy in any way. It will not affect your local source code in any way. So if you're working on something, let's say you're running up to 5 o'clock, your VPN's about to die, you want to see what's going on the server so that you can keep working on it, from your hammock in the backyard, then you can do a git fetch before you're done, get any remote changes on the server. And if I was in a new state here, I could do a git fetch. I could get that new state, and then I could decide what to do with it later. I don't have it in the slides. I'll get it into Discord at some point when we have a pause. There's ways you can basically write little bash one-liners so I have one that will actually, for all repositories in my top level directory where I store all my code, go and fetch all of the repositories. And I can just run that to see, I can get local versions of what's on all the servers for however many repositories. And it doesn't affect anything happening locally. It's always safe to do, and it always gives me that version of the history. Also great for if you're getting on a plane someday, eventually, hopefully, and want to be able to keep working on it without paying for the in-plane Wi-Fi. There's a couple of different workflows. And again, I kind of recommend that you go and check out this website. It itself is an open source project. So if you find that it's missing some feature or doesn't work the way you expect, you could contribute that back if you wanted. Play around with it and see, if I do a git rebase, if I do a git merge, right? This is a really safe place to do that. Keep in mind, it's not a full Git client. So there are some gotchas. Some commands just aren't there. But it's pretty good. So as you start getting into Git workflows and as you start working on other projects or seeing other people work on their projects, one of the things that comes up, which is largely a philosophical argument, is how should I structure my branches? And so there's a couple of different workflows. One of the most common ones, which I think encompasses a lot of the corner cases, is something like this. So it's referred to in Git circles as the Git Flow workflow. There's several different blog posts and graphs and explanations about it. So I'm going to hit this pretty quickly. But the main gist of it is that you have a main branch represented here by this blue line, these blue commits here. And that is your sort of golden copy, right? In this case, it actually corresponds to the released versions, which are these squares, are tags in Git parlance. So you have a tag that points to a particular commit. Then what you do, and so that's kind of always stable. And so the idea with this is master or main, your golden copy, that's the, barring any unknown bugs, that should be the copy that always works. That should be, if you're on that branch, that should always be a fairly robust working version of the code. So then what you do is you make a separate branch called often develop, that's represented by these purple commits down here. And that's where you do all your works. This is one way to get around that, is my code working in a working or a non-working state? So on develop, you can be a little more fluid. You can have commits where things are broken, and you can do all your work there. Eventually, you'll want to get that into a more published copy. And so that's where you can merge things back or merge your master branch onto a particular commit, which isn't well represented in this particular graphic. actually I think it's better here, where you'd have, actually it's not represented very well. I guess it's represented here. So you'd have this development state merged into your main state, and then you would tag it and say, okay, version 0.1 is this commit here. And develop was there, and then development moves along. Eventually, master main golden gets updated again there, and development continues along. Then your feature branches become kind of what we were showing in the website, where you have some branches. Maybe this one down here is still getting worked on. This one over here, I made a new feature off of the develop branch. I did some work on it. Someone else continued doing some work on develop. And eventually I go ahead and I merge those together, and development continues along. Again, later things get published, they get tagged as a version, they get shipped off to users. The flexibility, or some of the flexibility that comes with this particular workflow, is the introduction of things like release branches, where let's say, okay, I got development to this state here, this purple, get the laser pointer back. So I get back to this purple commit here, and I say, okay, this has all the features that I want in it. Now I'm going to go off. I want to polish this up so I can tag it for release. So then you can make a release branch in a release 1.0, and that can be where you polish your documentation or add your tests or fix whatever you need to fix. And then eventually that's what gets updated to your master branch and gets tagged as the particular version. Now all that documentation you probably want back on your development branch, so you'll merge that back into develop and keep going. But that gives you some of the flexibility there. The other thing it gives you is the ability, again, and this is just a workflow, there's not really any new Git concepts here per se. But one thing that might happen is you might say, okay, well, I'm over here, I'm working on version 2 at this point. But back in version 0.1, which for whatever reason I'm still supporting, someone found a really critical bug. And I want to go back and fix it. I'm going to fix it on develop because that's just good to do. But I also want to go back and I want to make a version 0.1.1, which fixes that whatever bug that was. So this is where you can git check out a new branch, git check out hotfix, git reset to v0.1. That'll move my state back to here. Pretend like I went back in the time machine and ended up back here. I can make my change on that hotfix branch. And then I can go ahead and work on it, fix it, and then turn it into a new release 0.1.1. Delete that hotfix branch and go back to working on develop. And so this is kind of all, I don't know if it's quite all, but it's pretty deep in far as what sorts of workflows you can get out of a Git repository. But it's all really just permutations of this, having different branches and then where they come from. This is just showing some of the examples. Okay, we mostly already talked about remotes, but this is the idea that you'll have some remote server, oftentimes could be multiple different remote servers, and you have a number of different users or developers that are working off of that same copy. And so that's what we were showing before. And then we already did this demo, so I'm just gonna skip this. All right, so let's get into some real changes here. And some of this, if you were at the workshop, will be a callback, and part of that is because actually at least one of we actually submitted a pull request back at the workshop that is still kind of hanging out. So maybe we'll nudge someone in Discord here to go take a look at it. So there's a question I want to go back to that just came in Discord. So the question was, if I go back and I make this hotfix off of 0.1, then is that automatically applied to 0.2? And the answer to that is no. So this commit here is only off of this commit. If I wanted to also apply this hotfix to this branch, I would need to go check out a new branch here, hotfix 0.2, and then I could take this commit here, and there's a command called cherry pick where you can just take this command, or take this commit rather, and replay it off of this. And you'd have to do that off of all the versions that you wanted to update. Or you just go in and make the same change and make a new commit and make a version 0.1.1, 0.2.1, and so forth. And that is about as onerous as it sounds to go back and patch all your previous versions. And that's why it's somewhat rare, mostly because it's expensive in terms of time and resources. to support multiple different version streams. So for instance, you might say, okay, well, I'm only really, once I get to 1.0, I'm really going to only support 1.x versions. I'm not going to support these. These will have a bug. My advice to you is don't use those, use version 1 instead, or after I have my hotfix, version 1.1. And so that's one work fix. If you wanted to also get this fix here into your version 1.0, there's really no way. Once you tag it, while it's not technically impossible to change what that tag is pointing to, convention would say don't change your tag, don't change the code that corresponds to a version out from under your users. Make a new version 1.1 that has the same fix in it, either applies the same code, and just go forward. And then your users should update to version 1.1 of your code. So that's kind of how that will work. And I can take some more questions about that later. So let's get into it. When we talk about working on open source projects, typically that means that you've given the source code to other people, right? Once upon a time, this was hosting it on your personal website. Nowadays, that's hosting it on one of various code hosting platforms. Here are a couple of the biggest ones: GitLab, GitHub, Bitbucket, SourceForge. GitHub's kind of the 800-pound gorilla in the room right now, with some of the greatest mindshare, but that is and will change over time, right? Different services offer different features, and there's pros and cons to using different solutions. I'll note that because we're talking about open source, this is mainly going to be focused on interacting with these public repositories or these public code hosting platforms. I'm less sure about SourceForge, but GitLab, Bitbucket, and GitHub also all have on-prem solutions. So you might have a GitLab server or a GitHub server or a Bitbucket server installation on your local enterprise network. And that's where you might have multiple remotes coming into a project. So different code hosting platforms. I'm mostly going to focus on or show examples from GitHub because that's where a lot of the code is today. It's just kind of the state that it is. Okay, so this is literally just stolen from my previous workshop and is trying to now start to show while we'll get to talking about writing your Python package, the making meaningful contributions to open source projects, right? This is someone else has an open source project, I want to contribute to it, is not as hard as you might think. So in this particular example, what I'm showing here is I was reading the ADHD project github.io website. So they have a Git repository. It's the ADHD project website. Here's the URL where that up to this slash here. This is the URL for that project. In that project, on that website rather, I was reading around. I happened to be reading the Wild West Hackin Fest 2020 labs page, and I noticed that they had these labs are brand new. We wrote them based off the labs in the documentation. That documentation is here, but this here is not a link, right? This is just text in here, so there's no way to get to the actual repository. So maybe that would be a nice feature. So what you can do then is you can go on GitHub and you can find the project. You can dig around in the source code until you eventually find intro Wild West Hackin Fest 2020 deadwood.md, which is the actual file that is the source code for this website. And so in that, you can then, as soon as my browser catches up, you can go ahead and dig around in here, and you'll eventually find that same issue. I'll make this a little bigger. There we go. Okay. So I'm in the project. I've dug down to that path. Here's the thing. If it's a GitHub project or a GitLab or a Bitbucket or whatever, you actually don't even need a terminal. I show the terminal because if you understand that, I think it's much easier to port to other things. But a lot of other tools make things quite a bit easier. So GitHub, for instance, has a UI where you can come to a project, right? Someone else's project. And if you have an account and you're logged in, you'll see a little pencil here. And this is saying to edit the file in your fork of this project. And so if I click this, it'll actually open up, it'll make a fork for you, which you don't really have to know, but a fork is a copy of a repository that points back to some other repository, basically a new remote that has some knowledge about the remote it was cloned from. And I can just come in here in this editor, and I could just change this as I see fit. I actually don't need a terminal. I don't need any fancy code editors. I could just, in the browser here, type this out, ADHD project.github.io. All right, so there's my change. For many types of files, Markdown being one of them, there's an edit file tab here, but there's also a preview changes. And so you can click that and it will render the Markdown. Here it's rendering this as a link. I could click on it to make sure it works. Yep, that works the way that I thought it was going to work. And so if I scroll down this page, and this is kind of what, there's just some pointers in the slides that I'm going to kind of slowly stop going back to, down to here. So if you scroll down this page after you've made your change, you can see proposed changes. Okay, I updated and this is where you can put that short description and your longer description. So here in the short description, right, I'm just going to demonstrate one thing. It will pop out this pro tip to you that I mentioned earlier, which is that a commit summary, aka this first line, should be fewer than 50 characters. And then the extra information should go in the extended description. So it'll kind of help you a little bit in this UI here. You had multiple email addresses you could associate. You could choose which email address to associate the commit with, and then you could propose the changes. And that will end up turning into, I already did this a couple months ago, September 25th. That'll turn into a pull request to the project. And so this is the one we actually made in the workshop back then that's still kind of hanging out, waiting. GitHub, on its end, will do the hard work of having come up with a branch name. It made the fork of the repository. So you don't have to get on the command line if you're not comfortable with that or not comfortable with that yet. And you could come in here, you could add comments. If the maintainers of this project had questions, you could have a dialogue here. There's ways to do code review in the actual changes. You can come in here and leave comments on files. And so this becomes kind of the interface you can do your development work with, or do your contributions with. You can also see the individual commits. In this case, there was only the one. And then what files changed. So this is, again, it's a very low barrier to entry method for making a contribution to some other project, right? You don't have to be a developer. You don't have to get super deep into how do I clone things? How do I get Git installed? How do I do this? How do I do that? A lot of things can be done straight from the UI. So this was one example here that we went through. Another example was I ended up just pulling mostly Black Hills related projects to see where I could do pull requests for the examples. So this would be another one. I'll just make this bigger and not bother with presenter mode at the moment. So I was looking at the Rita documentation, and last year, 2020, was my year to learn Docker, or try to teach myself Docker. So I was looking at the Docker instructions for Rita, and I stumbled upon in here, there's a note in the text that says that you can change the Rita version with this Rita version variable. Cool. But then down in the example, it just says version. So expert version equals versus Rita version. Okay, is it Rita version or is it version that I'm supposed to change? Spoiler alert, if you dig into the actual code here, what you'll find is the answer is it should be just version. So I went ahead and I dug into the code, and here's where you can see that it's using version. So the code example is correct, and the doc string is what's incorrect here. So this little paragraph there is wrong. And so this could be a contribution. Again, from this project, I could just go ahead. I need to be on a branch. So let's say I'm going to be on the master branch. You come in here, you could edit this, right? Let's say you decide, I don't want it to be version, I want it to actually be Rita version. That's the one I think is better. You could propose the change that way. So that was one example of, again, you don't have to have a terminal, an editor, any knowledge of Git, a Git client. You can be on any platform. All you really need is a web browser and a GitHub login to do those two examples. And this trend of having things, having particularly websites, as Git repositories, open source Git repositories, is, in my opinion, increasing. And it's become a lot easier to where there's actually now different ways to integrate that functionality directly into your website, where I don't have to go like, is this a GitHub project? Go find the GitHub project. All right, which code file, which source file corresponds to that website page? But you can actually integrate things with, in this case, the Docker documentation just has a edit this page button. And you can click that. And if it was your first time, it'll take you to that page. I don't have access to the Docker GitHub.io website repository. So it'll tell me I can fork this repository and give you a link to go learn more about forks, which is going to be outside the scope of this talk. And it'll walk you through. Then it will land you on this page, basically what we were looking at before. You can go ahead and make whatever changes you want, commit them directly through the UI. You can choose which branch you're going to do that on, whether you make a new branch or use the default branch. And like I said, you can do this all right in the web browser. All you need is a login to the code hosting platform. And so the parting shot from the workshop then was, as you're out there, as you're listening to various Wild West Hackin Fest talks, and you get pointed all these great links to different projects, right? Rita, Mimikatz, Metasploit, PragMac Exec. Go and look at them. As you're reading around, hey, you might find a typo, right? Developers certainly not immune to typos. It's fairly low energy to contribute those changes back. I put a note down here in the slides to myself that this Metasploit framework example was actually inspired by real events. I was doing a pen test in the fall, and there was a module I was using that had an add admin user function. And since this was a test, not anything more than that, I wanted to be able to remove that user, and there wasn't really a way to do that. So I'm working on a contribution to add that remove action to that particular module. So just different examples of that. Like how could I make this better? How could I leave this project a little bit better than it was when I found it? The other set of lists, this is a fairly random set of lists. There's a concept in the open source community of awesome. So there's awesome lists of things. And which one is, the most awesome for any particular category is obviously open to debate, but these are effectively just lists. If I click on this active defense one, then you can see it's just a list of resources, a list of other projects, other websites, tutorials, different things like this. And let's say you come to this and you're looking at it and you're like, oh, well, I know another annoyance tool that should be included in this list. You come up here, go to the file, click edit, and contribute like, hey, I know another resource that should be included in that awesome list. And now you become a contributor for now and forever to that project, to that open source project. So again, another just really straightforward way to start contributing to a project. Okay, I'm gonna pause there to take a short break before we then dive into the last part here, which will round us out. Or actually, okay, I know a little bit about Git. I want to make my first open source project. I don't want to contribute to someone else's, or maybe I will, but that's not what I want to do right now. I want to make my own project. There's a link to a pull request about CISA.gov that I'm going to zero in on for a second, which is there's actually been a shift in certain corners of the US government to have more policies be open source. And to that point, I believe, if I'm remembering correctly, that all of the latest CISA emergency directives have all exist they're on a website somewhere. And that website is itself an open source project that they don't really take contributions because obviously they want to control the content, but in theory you could. There was one project, it was 2016, where there was an OMB policy actually related to the federal open source code policy that I was somewhat involved in, where they actually did the government's request for comment period as issues on a GitHub project. So they published the draft as a GitHub repository and said, here's where the comments go. And anyone who sent in comments, even if they didn't do it through GitHub, those comments got tracked as issues on that repository. And so they're still out there. You can go read, who said what about that policy, and then any conversation that happened sparked from that comment. So just a interesting thing. And I know of at least one case where there actually was, I think it was a local government repository where they actually did update some policy or some official document that was based on a GitHub pull request. So there's at least one example I know of out there for that. And I personally hope that continues. Okay. So let's say you want to dig a little deeper. You don't want to just be confined to the web UI for whatever code hosting platform you're on. And instead you want to actually get into doing the development work, right? This was on releasing an open source project. So let's release an open source project, and we'll see if 38 minutes is enough time to show an example here. Kickstarting your development. There are a lot of choices out there for what you do with your development practices. What language are you going to use? What editor are you going to use? What operating system are you going to use? What shell are you going to use? And there are all kinds of philosophical arguments about them. What I'll say is, don't worry too much about what the perfect solution is or anything like that. When you're first getting into it, find the one that works best for you and just start using it. Because the reality is that initially you won't know why you would want to choose A over B. And it's not until you have a little bit of experience with A or B that you'll learn why you might like the other one more or less. So my advice would just be, if there's people around you you're working with, or other people you're learning with, or someone else who you can get to mentor you, just pick whatever they're using. And that way you have someone you can ask questions with, right? Someone who's more experienced. You can ask them questions and be like, hey, I did this. It didn't work as I expected. What do I do? Similarly, I know some of the Black Hills related Discords have various channels for tool help. So if there's a tool there that you like, or a platform you like, go ahead and dive into that. For me, I try to be mostly a polyglot. I try and use pretty much all of the tools. So at the moment, I'm on Windows 10. A lot of what I do is in Linux. I sometimes use a Mac OS host instead of a Windows OS host, or Windows 10 host. So the tools I use really vary, and I try really hard not to get stuck too much into any one particular tool. For me, Visual Studio Code with the Remote Development Toolkit is what I use everywhere. I really like that platform. That's a follow-on from Atom and Sublime Text and Vim before them. If you're familiar with any of those things, that's how I got to Visual Studio Code. Visual Studio Code is not Visual Studio, and I'll actually be pulling up Visual Studio Code here in a minute. Windows 10 WSL2, the Windows subsystem for Linux, has been an awesome addition to Windows, and that's what I'll be using on Mac. Homebrew, it's also available on Linux. And then for my shell, usually ZSH, although Bash is often a default, so that is a sibling to ZSH, so it shares a lot of the syntax. And then, as I mentioned earlier, I've been trying to use Docker for more things. So for today, I'm on Windows 10, Windows Subsystem for Linux 2, Docker, Visual Studio Code. That's what I'm going to use. And so I've got my terminal window here. If anyone thinks the font is too small, shout out at me. I will be making the window bigger in a little bit. I'm not necessarily expecting, this isn't quite a workshop, but it's somewhat close. I wanted it to be workshop-like. I wanted people to be able to go back after the fact and actually follow along with what I'm doing here in the recording. And so here I'm in some directory, and I could have done whatever to this shell in advance, and you might not have any idea what happened. So to try and, as I say here in the slides, prove that there's no tomfoolery happening that you're not seeing, what I'm going to do is I'm actually going to just start a new Docker container, and I'm going to do everything I'm about to show you in a brand new Docker, in this case Python Slim container. So this is basically a bare bones, pretty much nothing installed into it container that we'll use for this workshop. So I'm just going to do a couple of convenience things. This isn't really a Docker tutorial. But effectively what I'm doing here is I'm telling Docker to run a new container called Python Slim. The highlighting doesn't show up so well. Called Python Slim. I want to name it Wild West Hackin Fest. I want to run it in interactive mode. The -IT is interactive and with a terminal. -V, I'm going to mount a file system. So I'm going to mount my present working directory into that container at the /code location. And then by default, it will just launch a Python shell. I don't want that. I actually want a full bash shell. So I'm going to tell it to run bin bash inside that container. And so because this is Docker, this is pretty quick. So if I go ahead and I look at this, you can see that even aliases that I just cannot get out of my fingers are here. But I end up in a root file system. There's nothing really in my home directory other than what comes stock, right? This is the bash.rc file from 2010 that just has shipped with the, I'm not even 100% sure which OS this is. Let's see, are you Debian? Yeah, Debian version. So Debian 10.7 looks like what this is based off of, this particular package, or this particular container image. Okay, so I've started this container. I'm just going to open a new window here and just show that it's running here. It's called Wild West Hackin Fest. I have this other one that was my prep container. I could do this in the terminal. Oh, I didn't mention this is actually the Windows terminal, which is itself an open source project from Microsoft, and I'm fairly impressed actually with this particular terminal in Windows. But for the sake of this argument, we're going to go over, since we're writing code, and we're going to do this in Visual Studio Code. Okay, and this is where we'll end up spending most of the rest of our time. So once you fire up Visual Studio Code, you might end up with a window like this. Because I have the remote development pack installed, I'm going to click down here, this little green button. It gives me a couple of different options. I can connect to a WSL session. I can connect to an SSH to some other host. But it also has, which is newer to me a little bit, where you can connect to a container that's running. So I'm going to tell it I'm going to attach to a running container. And I can see the two options here, Wild West Hackin Fest, the one I just started, and then Elastic, however you say that. So I'm going to connect to the Wild West Hackin Fest container. I can close that first window. I don't need that anymore. And I'm here. I'm in root ccd8, blah, blah, blah. This is some hash for the host name. You can see that matches over here, 6cd8, 6cd8. And then the first thing, by default, it doesn't open you in any particular place. So I'm just going to say open folder. Actually, I'm not going to open the folder quite yet. So this is in the file system. I could open some folder inside of that container. And then I could go from there. So this is where I'm at. And now we're going to go through and actually build our open source project. So this is what the rest of the slides kind of go through some of what we'll be doing. But I rolled a high score on my live demo dice this morning. So we're going to do this all as a live demo until it all starts to fall apart. I am going to make a shout out. A lot of what I'm doing is based or is explained why you would make these choices by Marcello in a Black Hills webcast webinar from, there was one in October and one in December for Pretty Little Python Secrets 1 and 2 that explain why I've made some of the Python choices I've made here. But for right now, just kind of take them for granted. The main thing is I'm going to use Poetry to configure this project, which I will say that I have just, I will flat out tell you right now, I have the documentation right here, because I literally this week rewatched that video, decided I should use Poetry instead of what I was going to do for setting up this project. And last night taught myself Poetry and rewrote what I'm about to show using Poetry instead of sort of more native Python tools. So that was a wise decision. We'll see if that comes back to bite me. Okay, so if you're new to Poetry, right, this is a brand new image, right? This makes no assumptions about what is on this system right now. But I do have a version of Python, right? This is a Python Docker image, so you would expect Python to be there. In this case, it's 3.9.1. This particular image tracks kind of the latest the latest fully released version of Python. And so I'm in my home directory /root, home directory. And so poetry, how do I get it? Do I have it? I just type version? No. Poetry? No. Okay. So I have no poetry installed. So various different ways. In his talk, he talks about using pipx, which I would recommend for installing standalone tools. I'm going to use a slightly native version here, where I'm just going to use Python 3. Since this is a new enough version, I can tell it to run the pip module, the install command of the pip module, or the pip command, and poetry is the thing I want to install. So I'm going to go ahead and install that. There's many other options you might choose to use depending on exactly what you're doing, but inside of a Docker container, this is fairly safe. I will echo something I don't remember if he said quite explicitly, but never, ever, ever, please pip install something in your native host with sudo or as root. It will cause you no end of grief. Virtual environments, pipenv, pipx, these are the things you want to use instead, or in this case, Docker containers. Okay, so now if I just reset some things, if I do poetry version, I can see that poetry is now installed. It's at version 1.14, so that's the latest version that's available. So what do I want to do? Well, I don't know anything about a Python structure. Or maybe I have some outdated conceptions of what a Python structure should look like. So let's just throw those away and let's just try and eat the poetry dog food. So we're going to say poetry new. Well, here, let me just show a couple of things. Since I stated that we're making the assumption that you don't necessarily know anything about development, you don't know anything about tools, the command line, you know a little bit about the command line. That's kind of where I'm assuming we're starting from. Most commands, if you run them with no arguments, will give you some help page. And I highly recommend any projects that you write will do this. So if I just run poetry with no arguments, it'll tell me a little bit about how to use it, tell me about some global options, and then tell me about some of the subcommands that I can use. And you can go back to their website and read all the documentation about what these different commands do. In this case, there's some projects set up. This is basically what we're doing here. So if I was just looking at this, let's say, again, I'm on a plane, I have no Wi-Fi. All I have is the tools I have. You can see there's a subcommand here for new. So it creates a new Python project at pat. Okay, well, let's just see. The other thing you can do is you can use a -h flag for help, or --help if you want to spell it out all the way. And most subcommands, certainly the ones that are better written, will have that for their subcommands. So if I run poetry new -h, I'll get the help specifically about the poetry new subcommand. And I can see poetry new, these square brackets mean that it's an optional path. This pointy bracket means that I need to fill in something there. This pointy bracket here says I need to give it a path. Okay, so I'm going to make a new poetry project. And what's this name do? Okay, name, set the resulting package name. So what this is useful for is if you want the sort of top level directory, which is often what's going to correspond to the Git repository, to be a different name than what you want the actual Python package to be called. And that Python package is what controls when you do a import something, what that something is. So that's a little esoteric in. Let's show an example. So poetry new, I'm going to say that I want my Python module to be called awesome, because that's what I think this is going to end up being someday. But I want to put it in a directory that I'm going to call awesome project, just arbitrarily. So I can do that, create a project, package awesome in awesome project. So if I do an ls, I'll see awesome project. That's my directory. And then just into this. If I look in that directory, I can see there's some stuff that it created. So it created some tests, created this top level file, and here, let's just go inside of it, is this awesome package, lsl awesome, and in it is just a default dunder-init.py file. Again, Marcello talks a little bit about what all these files mean, so we're going to mainly focus on the, how do I make use of them? If I look in that file, what does that look like? okay, it just has the version number initially. This is the one that Poetry just gave it, right? New project, fine, 0.1.0. And it'll just go through there. Now, because I'm going to keep doing LL all over the place here, if I don't save myself, I'm going to use alias. I'm going to do a couple of helper things for myself, hopefully for you as well. Equals. Okay, so now when I do an LL, I'll get a long listing, and I'll get some color for so directories stand out a little from individual files. Okay, the other thing I want to do, so I have my code directory here. Great. Now it'd be really nice if I didn't have to do all the editing of these files from the command line. I love the command line, but there's a reason why editors are popular. Again, they're looking awesome, and tests while I got this going. So since we connected to our container, this Visual Studio Code workspace window will allow me to open a folder. So if I click this open folder now, I'll actually see that awesome project directory. I can select that, say OK. Before I do that, I'll also say you could select a local directory instead, but we're not going to do that. So we're going to connect to this awesome project inside of here. It, in this case, reloaded the window. And I think it's going to lose my alias, of course. La, la, la. And I could put this in my .rc file so it would save, but I'm going to do that real quick. All right, never mind. No, I'm not. Well, we'll just redo it if it falls apart again. All right, so now I've got a directory. This was generated by Poetry. There is nothing about Git in here. So the first thing I want to do, since this is an open source, I want to release this project somewhere, is git init. So if I'm on the command line and I'm starting a brand new Python project, git init is the first thing I'm going to do. And you could give this an argument, which will create a Git repository in a directory that has, in this case, the name ASDF. If you don't give it any arguments, it uses the current directory. And Git's not installed, again, because this is a container. So this is really proving to you that I am not doing any tomfoolery here. So very quickly, apt update, apt install Git. So this is some of the setup you would have to do in your environment, potentially, depending on what tools you have available. Okay, so Git is installed. So now I can git init. So initialize an empty Git repository in this location, root awesomeproject.git. Cool. If I look at all the files here, I can see there's now this .git directory. And if we just peek inside of that, this is what it looks like. And for the most part, this is all an internal directory that you should really not mess with directly. It does have some things, like it has that head file that's telling you which branch it's pointing to. In this case, it's defaulting to master. It in here inside of the refs directory tree is where all the commits, the actual content of all the commits will get stored, and then all the rest of this is for different pointers and basically all the Git internals. So all that really to say, if there's a .git directory in this directory or in any parent directory, then you're considered inside of a Git repository. So if I do git status, which I mentioned before, we'd be giving a show, then I'll see the status of this repository. So this is telling me I'm on the branch master, which is again just the default name. There are no commits yet, so I haven't committed anything. It's a brand new repository. And it's telling me about these untracked files. So there's a readme.rst, pyproject.toml, awesome, an awesome directory, and a tests directory. If an entire directory is unknown to Git, it just rolls it up to the top directory. That's why you see it here. One other interesting thing to note is Git tracks files. It does not track directories. So there is no sense for adding a directory except to say that you're adding all of the files inside of the directory. So if I just do like make dir foo and then try and git add foo, nothing changes because there were no files inside of foo. So just a minor note for folks. Okay. So there is our project. There's our Git repository. I can start things off here. It is fairly conventional. So if I want to actually start tracking this project, let's say I have this new project, it's brand new, I've done nothing to it. This is a great starting point to have, as a rollback point. So I'm going to go ahead and I'm going to git add everything. So I just want to add everything into tracking. So here I still have no commits, but then this is describing the staging area to me. So changes to be committed, that's referring to the stage area. New file, readme, new file, awesome/init.py, py project, and so forth. These are all the new files. If these were files Git knew about and they were changed, they would just be marked as modified. And again, modern versions of Git will actually give you a lot of help for how you can, what your next step might be. So what I'm going to do is I'm just going to say git commit. I'm going to give it a message. Conventionally, the first commit of something is often called just initial commit. In this case, Git is complaining. Again, I told you this was not my normal environment, so it's complaining because I don't have user configuration set up here. So I'm just going to set this real quick. And it didn't do the commit. It stopped before it did the commit. So we'll do that again. And there we can see it's on the master branch. There's the hash for it. There's the message. Some files were created. 5 files were created. There were 21 lines in all those files. Some mode information in the files. Now, if I do that git status, which is something I do just all the time, it'll show that I'm on the branch master. I have nothing to commit. Working tree is clean. If I was to make a new file, that would show up as being an untracked file. If I, let's say, came in here and said, hello, Wild West Hackin Fest, into my README, that would show up in Git status as being a change that has not been staged for commit. So I've made a modification to README. It is possible that a file here can show up as both modified and unstaged and also be staged. So this is where you can stage pieces of a file without staging the entire file. So that's that. The one other command I'll just show briefly for completeness is git diff. So if you do git diff, it'll show you what the changes that are unstaged, by default unstaged, and you can add the staged flag to show you the changes that are staged for commit. Okay, there's a whole bunch of git commands. Again, explained a little bit more elsewhere. So now what do I do with this thing? Well, there's a couple of things to keep in mind. One of them, which I guess actually would have been easier to do previously. We'll do this the full way. So one thing you'll probably end up needing to do is generate an SSH key. In this case, I'm going to do that here. Just make a new key for this particular demonstration. That ends up in my home directory, in the .sh directory. And so what I'm going to do is take the public side of that key. This is the part that you do share with others. And I'm going to say, okay, this key identifies me. Really, the key is over there. I'm going to copy that. I'm going to now start doing the other side of this. So I have a Git repository. It has something in it. It may not be the thing I want, but I have something in there. What can I do with that? So first thing, I'm going to take my Git SSH key over here, and I'm going to add a new key that's inside of my container. And good. So now that key is associated with my account. So now if I come back over here, once you have your profile, which you can get back to from going up here in the menu once you're logged in this case, your profile or your repositories is really where we're trying to get to. You can see a list of all the repositories that you have associated with your profile. So in this case, a lot of these are forks because I tend to make little contributions to a lot of projects. And then some that I'm more involved in myself. And I have some new project, right? We have this project over here. Let's say we were working on it for more than just generated from the template. So it does something a little more interesting than this, which we'll have time to add in a bit. Now I want to actually share that with the world. So what that'll look like is again, this is just for GitHub. The UIs are similar but different for other tools. I'm going to come into the repository page and I'll say new. So I want to add a new repository. So I'll click this green button here. Now, repository template, there's all kinds of templates that you can pick from. Basically, individual projects that you're affiliated with can be marked as templates. There's a way to set up a project as being a template, and then you can use that as a starting point. So it'll have all the files in it initially. I'm going to ignore that for now. Repository name. Oftentimes, certainly by default when you're cloning something, this will be the directory that you're in, or the sort of top level folder name of the project. So in this case, we made it as awesome project. So that's what I'm going to pick here. So awesome project. And it's available because I don't have a project named that already. I can give a description if I want. This is our awesome project. This is really only relevant in the GitHub UI. I can choose whether that's public, everyone can see it. If it's open source, that's probably what you want. Or if it's private, only I can see it and whoever I give access to it. GitHub also provides some functionality for initializing a repository by adding a README, adding a git ignore file, choosing a license, so to give you some options for which license you want to start with, as well as some information about how to choose a license. And it will say this will set main as the default branch, which is just how I have things configured. Okay, so here we're kind of just going with the default options. So we'll create the repository and then see what GitHub tells us next. So next thing we do, we've got our project. We're going to go ahead and create it. So here it's telling us some of the stuff that we kind of already know. So this is kind of what we already did. We created a new repository on the command line, git init, git add, git commit. In this case, it's giving us a little help that we need to make you might want to make the branch name match, which is actually something I'm going to do. So I'll go ahead and just paste that in here. If I do git status, now it'll tell me I'm on branch main instead of on branch master. And then the next thing it'll instruct you to do is to add a remote. So this is how you actually set up one of those remote server knowledges. So I'm going to add a remote, git remote add, origin is what I'm going to call, what I want to refer to it as. That's just a convention. That could be whatever name you want it to be. And then this is the URL. And this URL comes from right here in the Git UI. You could also use the HTTPS URL if you prefer. That one just doesn't use SSH keys. It uses a username and password instead. So I could do this in either window I feel like, but I'm going to go back to my code editor here. Git remote add. Cool. All right. That didn't seem to do much of anything. So what I can see how it did is if I do git remote -v, that'll list out what remotes I'm connected to or what remotes that I'm trying to track. And so if I did a git fetch, this is the first time using that SSH key I made, so it's trying to authenticate me. I did a fetch, it didn't find anything new, which makes sense because it's an empty repository. If I did a git pull, similar, kind of gives me a little more errors of like, hey, there's nothing there. And so what it's really wanting me to do is git push. And that's what's over here. The first time you push a branch, a new branch, you need to tell your local copy which branch on the remote side you want to track. So that's what this -u origin main is. So I'm going to kind of gloss over exactly what that means, but effectively it says I have a local branch main. I want to push it to the remote I call origin with at a branch on that server at that Git repository called main. And this -u says I want my local branch main to keep in sync or try and keep in sync with that origin remote's main branch. And so this will go ahead and this will actually push the commits that I made. You can tell you it's making a new branch on that remote. Branch main is set to track the remote remote branch main from origin. So that's kind of the Git words for what I was describing. If I come back to the UI here, I can refresh the page, and there's all the code that we just created from the example. So at that point, I have technically released an open source project. It doesn't do a whole lot, but it is technically there. And that was, what, something like 20 minutes worth of work with quite a bit of exposition. So now I have an open source project. I could take this project, I could copy it in Discord, and everyone else could go look at it and open their issues and open their pull requests and tell me, what I need to improve or do different or make better. I'm not really going to go into the whole GitHub UI for everything it does, but it gives you some functionality for making changes and seeing who's contributed and looking at your code and contributing your code to other people's code and so on and so forth. But for right now, I'm just going to assume you're working on a project. Let's start working on a project. So in the 7 minutes that I have left, we'll see how much actual open source development we can get done. So the first thing I'm going to do is check what my status is. Okay, I modified my README. How did I change the README? Right, I added that line to it. Sure, let's go ahead and keep that change. Right, added hello to README. So this kind of starts to inform the questions earlier about what goes into a commit message and how often should I commit. So you'll end up seeing me through how often I'm committing here. So now if I run git status again, it's telling me that my branch is ahead of the remote server, as far as I know, by 1 commit. So I can git push, and that commit will then go and show up. If I come back over here. So I added the README. You can see there's the commit message being shown, and there's the actual message. And it's being rendered by GitHub, helpfully right there. Okay, so there's a fairly minor thing. Now, there was some discussion in the pre-show banter about writing things in Markdown. I'm actually a fan of Markdown, so I'm going to say this readme.rst file that it created, that Poetry created by default, I actually want to rename that. I don't want it to be readme.rst. I don't like restructured text quite as much. I'm just going to rename it to Markdown. So I'm going to move that file. I'm going to rename that file. Git knows that I'm renaming it, so I'm just going to go ahead and rename. Convert readme to Markdown. Now, that really just changes the file extension. It doesn't actually change the content. Here, this window is still pointing at readme.rst, so I'm going to close that one and open the Markdown version of it. And then if we go back to the slides and you kind of follow along, this next is just kind of some of the things that I'm doing. So I'm kind of going to run out the slides verbally here, but some of the things you might want to do, the Pi project, when it created the new thing, didn't know who I was. There's probably a global config option I haven't found yet that tells me how to fix that, but I'm just going to do something like this. Save that. If I do my git status, I'll see that one file changed. If I do a git diff, there's my change. Set author name. So there we go. What else might I want to do? Well, if I'm making this project, right now it's all it knows is its version. That's not super exciting. So let's go ahead and let's add a new file. So we're going to add a new file. I'm just going to call it stuff.py. So now I have a module called stuff in my awesome Python package. So how I would refer to this in Python would be from awesome import stuff or import awesome.stuff, something like that. And let's say in this example, I want to be able to, let's say I'm doing some web scraping. That seems relevant recently in the news. How would I do some web scraping? Well, you're probably, thing you're doing to interact with a website, you're probably going to end up making use of the requests library. And so Poetry has a nice way of adding dependencies into it. This is what Marcello was getting at with managing the dependencies here. So I'm going to tell Poetry to add a new dependency. I'm going to tell it to add the requests dependency. And so it'll go through and it'll create its virtual environment for this project. It'll resolve the dependencies. It'll install the dependencies, and it'll install the requests library. So if I come back over to this, the Pi project, it added this new line here. And so I can prove that to you with the git diff command here, where it'll tell me, I added a new line, requests. and I'm saying I want a request to be at that version. I think this is at least a version 2.25.1, I think, or it's pinning to that specific version. I haven't quite learned all the nuance of the poetry syntax yet. So, but there it is. It's in my dependency list. So I'm going to say git commit. I'm going to commit that requirement for that dependency. So I'm going to say commit added dependency on requests. Okay. So if I'm wanting to do development for myself for a Python project, since it's an interpretive language, I often like to drop into a shell. So a Python interpreter, and do my development here. And then sort of once I know sort of interactively where I can make mistakes and change things and be a little more interactive, then I'll take this and put it into a script. So I might do something like import requests, as I keep a close eye on the time here. And then we're going to say, let's say I want to get a response to a page, or I want to call the requests, use the request package. I want to call the get method, and I'm going to get, let's just say, google.com. So this is going to do an HTTP request to google.com and return that. Okay, so I get this response object back. Okay, and let's say I want to save that. So I'm going to say r equals that. So now I can interact with that thing. If you read the request documentation, you'll learn such things as it has a status code. So in this case, it was a 200 status code. And there's also a way to get, using a text method, to get the actual text of the page that it returns. So this is the HTML of the page, google.com. So that's what google.com looks like, in case you're curious. Right, I'm in a Python shell. So let's say what I want to do, and just for the sake of time, I'm going to steal this from my other window from myself yesterday, is let's say that what I want to do is print out some information about this. So let's say, instead of R, so I can map to myself in the past, we'll call this response, requests.get google.com. And then I'm going to say, just copy this. I just want to print out the status code. So got status code 200. And also I'm going to print out the length of the page. So how long was the page that I got in the number of characters? Well, it was 12,805 characters long. Cool. Fun fact, trivia question. Now I actually want to do something with it. So I'll use this as my approach to doing an awful lot of sort of hacking while I figure out what I want some Python script to do. When I'm done, choose Python. I'll take whatever I have here in the terminal, and then I could copy that, paste it over here. I can get rid of the out. Oops, not that one. That one and that one. Take out the leading bits here. Maybe I want to get that requests module in there. Maybe I want this to be a get page. Maybe I'm going to pass in an argument for a URL instead of hard coding a URL. And I might do something like this to make my code. So I'm going to define a function, get page. I pass it a URL. I get the response. I print some information, and then I'm done. And then let's just say I'm going to define a main function as well, just to have, or maybe instead of main, maybe we'll call it demo. And demo is just going to call get page, and it's going to pass that HTTPS URL. So this is the demo. It's just going to pull google.com. And so we save that, and I realized that was an awful lot of Python to spew at you very quickly. If we look in here and we spell status correctly, we'll see that this new script here that I just created, this stuff.py file, isn't tracked by Git. So we'll go ahead, we'll git add awesome stuff. We'll commit that. Added my new module to get a page. And then I can push that to the server. And so this is what my workflow will look like. Right? I'll be working on this. If this was a Git Flow workflow, this would probably end up being the develop branch, and that's the one where I'm making all these changes very quickly. And if I run git status, I'm up to date with origin main, at least as far as I know. I could use it. I could run git fetch to confirm that I have the latest state of the server. The other thing I'll just point out real quick is that Poetry adds a lock file where it pins a whole bunch of things. This helps with reproducibility. You can choose or choose not to include that in your Python package. Again, Marcello talks about this a bit, and there's always the documentation on Poetry's website. But one of the things you can do if you read into their documentation is you can find that there's a way to add entry points, right? So if I write some code, I wrote this demo thing, I might want that as a command line tool. And so this will kind of be the last thing we'll show. And I'm just going to paste it in here because it's effectively copy and pasted from their documentation. So I can define that Poetry knows about these scripts. There's going to be a script I'm going to call demo. And demo is going to be a call to the awesome package.the stuff module colon the demo function inside of that module or inside of that module. And so it's going to call this function when I use this command line tool. So I'll go ahead and save that. Git status. You can see that I added that bit into the file. And so now I'm going to use Poetry install to just go ahead and install this thing. By default, it will install the current package or the project you're in. And what that means is I now actually have a demo command line. If I do which demo, don't do this to me. Really? Poetry run demo. We'll go ahead and run the demo command inside of that package. Yeah, I told you I was learning Poetry last night. And so what this does is inside of the context of Poetry, where all those dependencies are installed and managed, it's running the demo command, which is defined right there. Maybe I should make this a demo tool to make it stand out a little better. We'll reinstall things. So now my tool is Poetry run demo tool. And so it runs demo tool, which I've defined with the name there. And then this is the actual function it's calling. And you can see it's just passing google.com to this other function. That function's doing some stuff, printing out some information, and that's what's happening here. So if I did this on some different page or I added some different help text, right now it's all hard-coded in version 1 here, then I could continue to develop this to be some tool that does something more interesting, which kind of leaving that up to your imagination, what that might be. Just to recap what I did, I made some minor updates. I updated the authors. We actually didn't get to adding some of the development dependencies, but you can read about that in Poetry documentation. We wrote a little helper function here. I named it differently in the slides. Then run Poetry install to get it to a place where I can install it. Next, which we didn't really get into, this is going to vary by Python project. You can check out pypy.org for their documentation, or packaging. It's packaging.python.org. You can build the actual distributables with Poetry. This is one of the nice things that Marcello was raving about, and I agree. This is quite a bit easier than some of the native tools. Poetry build will build the dependencies, and then Poetry publish can publish them to the package index. And then it's really up to you. From there, you can publish your Git repository. We already did that by pushing it to GitHub. We can add unit tests. We might add continuous integration. We could add some documentation. We might want to make it be an argument where instead of having a hard-coded URL, it takes whatever it wants as an argument. And then, again, just calling out Marcello's talks. I put the links here for convenience. There's the 2 YouTube videos. And if you're hurting for ideas or you just want to play around, a lot of what I did working with some of this was to play around with my own blog site. So down here, this GitHub repo gets published through the GitHub Pages infrastructure and turns into my website. And so my website is an open source project, and that's just one example of what you might do as an open source project. If you were like, I don't know coding, I don't know how to write a tool, but maybe you can write your resume, right? So my resume is just a web page on the website these days, not a Word document. And that's it. So some of this is just recapping, but I hope that I've demonstrated that you don't have to know an awful lot about development to start making some sort of difference. And those differences build on each other. So as you make a contribution, that'll grow into something more. And so other than my obligatory callback to an XKCD comic, feel free to reach out to me if you have questions in the future. This is the end for now until we maybe have a part 3 of this. I have no idea.
Awesome, Ian. Thank you so much. You did a really great job. A lot of people had comments about how nice your kind of flow was while you were presenting. So
awesome.
That was awesome. There is one question I did see pop up a few times that I want to make sure we get answered, and that was any importive motive to use Docker over, I think it's virtual env.
Virtual env. Yeah. They're fairly interchangeable. Docker is just one way to structure your development environment. In this case, the reason I was using it was because just basically to prove that I didn't have anything else set up in advance, right? You could create a new VM and use that instead of Docker, or you could just install a fresh copy of an operating system and use that instead of Docker. I'd refer back again to Marcello's talks for some of the other tools and why you might choose one over the other. In this case, there was another sub-question to that one, which was what happens to this Docker container after I'm done with it? And in this case, what I was doing here with the code we had, this particular path where I have this repository was not the one that I mounted into the container. So when this Docker container exits, all this code is gone. The only reason it persists, or the only reason it would persist, is because I pushed it to GitHub, which in this particular use case for this particular webinar is a feature. In general, on Windows, I use WSL, which persists. It stays on my file system. It's not a Docker container, and I can keep my development and not have to rebuild all this every time. I think there was another question about Docker, which was, do I recommend any particular container? I think find the one that works for the tool you're using. In this case, I'm using the Python one just to have as a common starting point. I don't really maintain my own from there, though.
Cool. Awesome. Well, thanks again so much, Ian. Thanks to everybody who joined us today. Again, this was our first Hackin Cast of the year. I think it went awesome. I'm so excited for all the rest. Velda, I know you are too. This is going to be an awesome year.
I just, I wanted to pop on and just say thank you, Ian. That was a great webcast. Really.
Yeah, I'm sure we'll be having you back for more.
Absolutely. And Wild West Hackin Fest will also be right around the corner too. So
yeah, looking forward to it.
Thank you. And thanks to everybody who attended today. And, please check out our website. We have more things coming up.
Yes. Thank you again, guys. All right. I will see all of you soon.
All right. Have a great rest of your week.
Have a good one, guys.
All right. I'll go hang out in Discord for a bit and answer any other questions.
Perfect.
All right. Perfect. Thanks, Ian.
All right. Take care.